Part 2 of today's lesson, looking at exponential models. Remember, we have an exponential model when there's an increase or decrease by a common ratio, not a common difference. And this is similar to a geometric sequence. In real data, the common ratio may be approximately the same value. Remember, real data is rarely ever perfect. So we're looking to get a common ratio, but it might not be exactly the same. Here's an example. You are storing leftover chili in the refrigerator. The table below shows the temperature after T minutes in the fridge. So here are my minutes, and here are my degrees Fahrenheit. And if I start by looking for a common difference, I see negative 16, negative 12, negative 9, negative 6, negative 5, negative 3. The temperature is dropping at first by a lot. Negative 16 degrees it's dropping by. But then it levels off. And soon it's only dropping by 6 degrees, then 5, then 3. If I look at a ratio, remember that's when I divide. So 84 divided by 100, and 72 divided by 84, and 63 divided by 72, and so on. These are the decimals that I get. And while they're not exactly the same, you can see that they are approximately 0.90. And so if I wanted to write an exponential model, I would have y equals my a value of 100 times 0.90 to the x. Let's look and see what happens on a graph. So here I plotted my data points. And you can see that these points, instead of lying in a straight line, seem to curve. We have a big drop off, see? A big drop off. And then the drop off gets really tiny down here. Okay? And so when that happens, that's an exponential curve. So let's look at our calculator and see if we can get a regression model that's a little bit better than the one that I eyeballed. So remember, we go to our stat key on our calculator. It's right under the delete key. We're going to enter our data into edit. And I have stuff in there from before. So remember, arrow up, hit clear, arrow back down, arrow over and arrow up so the list is highlighted, hit clear and arrow back down. And now let's type in our data. So we have 0, enter, 10, 20, 30, 40, 50, and 60. And then we arrow up and over and we put in our temperature, 100, 84, 72, 63, 57, 52, and 49. And then I go back to my stat key. And remember, I go over to calc. And this time, I'm not going to go down to linear regression because I said that this looks like an exponential model. Well, that's quadratic, that's cubic, that's quartic. There's another linear regression. And this ln is a logarithmic, which we'll study in the future. But if I arrow down one more, I get exponential regression. EXP for exponential regression. That is the one I want. So I hit enter, and I keep hitting enter, and hit it one more time, and there is my equation, or my model. And so if we look, it says y equals, remember, let's round to 3 decimal places. And so this is my regression model. And this was my eyeball, okay? And so this one is the better model. And this is the one that we would use. Okay, so So now we are done with today's lesson. We're going to get more into regression models later on, but the biggest takeaways are look for a common difference, and in real data, that difference may not be exactly the same, but it should be pretty close. And if there's not a common difference, look for a common ratio. And if that's hard to find, then go ahead and graph it. Take a look at the graph and see what shape it is. Today's homework, you will be deciding just between linear and exponential. And then to get the best model, use the regression models on your calculator by pressing the stat key. Okay, that's it for today. Thank you very much and have a good one.